This brief video will review the solution to example 2 of the problem included in the Lesson 12 handout. In the previous video, the problem formulation was discussed. Here the assumptions are all provided, as given in the handout. The beginning workers employed by the firm currently are 50. The section on rows 14 through 20 deals with the labor plan for the company. They have 50 beginning workers, and 2 of the decision variables are the workers hired and fired each month. On the worksheet here, these are highlighted in yellow. This is just a reminder that these are decision variables. I'm going to enter some arbitrary numbers in the cells for the decision variables, simply so that when I enter formulas in the other cells, things will calculate properly and I can see the result. Line 17 we can think of as the current inventory of workers available. To calculate this, we would take the beginning workers, add in any hires, and subtract out any fires. This formula would repeat each month. So I'll copy this to the right. I need to come back up and address the beginning workers line. The first column is simply an assumption that's given in the problem as 50, but beyond month 1 we need to make the beginning workers for the month equal to the workers available in the prior month. The regular hours available is based on the assumption that each worker works 160 hours per month. So this formula would be the workers available times the regular hours per month, which is on line 4. The overtime hours used is a decision variable. It's possible, given the number of employees that we have, that we can assign a certain level of overtime hours, but we want to let the model choose whether this is the best option or whether we're better off hiring new workers. For now, I'm simply going to put an arbitrary number in these cells because eventually they'll be decision variables and we'll let Solver change these. The maximum overtime hours in row 20 sets an upper limit on the number of overtime hours that can be used. And this is based on the current workers available. We would take the workers available times the overtime hours maximum per worker, which is 20. Lines 19 and 20 will be included in a constraint when we use Solver. Again, every number filled in one of the yellow cells, or the decision variables, at this point is simply an arbitrary number. The total hours available for production is made up both of regular hours and overtime hours. The regular hours available is calculated on line 18. The overtime hours that we want to use for production is a decision variable defined on line 19. The total hours available for production is important for determining the production capacity. Since 4 hours are required for each unit, we need to take the total hours available for production and divide it by 4, the hours required per unit, which is defined on line 3. Okay, in this problem, the firm has 500 hours or 500 pairs of shoes that are currently in inventory. So we'll want to consider this when we address the inventory model. Because the shoes that are available for sale will always be equal to the beginning inventory plus the units produced in that month. The units produced will be a decision variable. This is defined on line 26, and for right now I'm simply going to enter a fairly large arbitrary number in there that would be big enough to meet demand. In the remaining lines here, we'll enter a formula for inventory that might be similar to a periodic inventory formula that you see in accounting. The units available to meet demand are the beginning inventory plus the units produced. The demand is simply defined in the problem. We can reference it from line 2. The ending inventory is equal to the units available to meet demand minus the demand. We still need to address the beginning inventory. For month 1, the 500 shoes on hand is simply given in the problem. For month 2 and beyond, we need to make the beginning inventory equal to the ending inventory from the prior month. So we've addressed both our inventory of workers and our inventory of units produced. The last thing in the model is to address the costs, which make up the objective function. We have regular labor hour costs. Since each worker is paid $1,500 per month, we'll simply multiply the workers available times the monthly wages of $1,500. I will enter each of these formulas in column B and then simply copy them over at the same time. The overtime labor cost would be the overtime hours used times the overtime wages per hour, which is 13. The materials cost are equal to the units produced times the material cost per unit. Material cost per unit is on line 10. Units produced are on line 26. The hiring costs are equal to the workers hired times the hiring cost assumption The firing costs are equal to the workers fired times the firing cost assumption per worker. And the holding costs are equal to the ending inventory times the holding cost per pair. So whatever we hold over in inventory from one month to the next incurs this holding cost. Now that these costs are entered for month 1, I'm going to copy them over to all the other months. My preference for doing this is to highlight the cells I want to copy along with the range of cells I want to copy these to, and then I can hit Control R for copy right on the keyboard. And that's of course just one way to copy those. What I would like to have now is row totals for each type of cost and column totals for the total cost each month, and in the bottom right hand corner a grand total of all costs for 4 months. One neat trick that a student showed me to calculate the sums of a table like this is to highlight the table, highlight one more row and one more column in either direction, go to the Home tab, and click the Auto Sum. And there it gives us the costs. Now we'll quickly go through the solver portion of this problem. We know that the objective is to minimize the total costs for the entire 4 months. We have 3 sets of changing cells, 3 ranges of changing cells, 4 total sets of decision variables. But we can highlight the ones that are together and separate them with a comma. So I'm highlighting each range of decision variables separated with a comma. We need to add the constraints. There are 3 sets of constraints. We have the constraints that the units produced have to be less than or equal to the capacity. The overtime hours used must be less than or equal to the maximum overtime hours. The units available to meet demand have to be greater than or equal to demand. Notice that if this constraint is satisfied, ending inventory cannot possibly be negative. Want to make sure the box is checked to make the decision variables non-negative. And all the formulas in this model are linear. So this is a linear programming model. If we click Solve, we find the optimal solution to the problem. So this concludes the video. Hopefully you can set up this model, and if you use the same assumptions, get the total cost that you see in the right-hand corner.